So, so who are we? UpDeep project has been running now for 3 years, and we are a group of geoscientists, geologists, exploration geologists, IT specialists, statisticians, and we have formed this project called UpDeep. We're from 5 different countries from Europe, including Finland, Sweden, Austria, France, and Denmark. We are a group of about 15 to 20 people. We've been changing along the way, and we have maybe 7, 8 different partners from these countries. So here are some instructions for the listeners at first. We have turned off all the cameras to avoid the overloading of the network, so you won't be seeing us presenters. I've just put those little pictures of everybody so you can get an image who's talking online. All of your microphones are switched off, and you can only be able to hear us presenters. At the end of every presentation, we'll have about 5 minutes for questions. This is a seminar about the project results, and I'm sure there will be a lot of questions about surface geochemical sampling and related issues. So you can please write your questions to the presenter in the chat window you can see on the bottom right corner of your software. So write your questions there, and us moderators, me and Vesa Nykänen later on, we will follow the chat during the presentation, and we will raise up a couple of questions from those questions that are being posed there. And in the end of the seminar, we'll have a longer period of questions. So please write your questions down, and you can ask them later on by the chat window in the end of this seminar. And you'll probably after that have some remaining questions and comments related to the surface geochemical exploration. So you can address them directly to the speakers and the UpDeep team using email. So I will be showing everybody's emails in the end. So our program today, Saku Vuori will start with welcoming words. Then Vesa Nykänen will introduce us to the UpDeep project. Jens Rönnqvist will talk about the geochemical consulting business that we have created in this UpDeep project. Then Pertti Sarala will talk about the standard reference material bank. We created the protocol during the UpDeep project. Jeremy Melton will talk about the streamlined surface geochemical sampling protocol. And before the break, Peter Filsmoser will present the statistical data analysis results from Finland, Greenland, and France. After that, we'll have about a half an hour break at 2 o'clock. And then we'll have 4 more presentations after. I will be presenting the results of the GEM web tool. It's a web tool we created during this project from scratch. Then Nick Cook from Mawson Resources will comment. He's an external person of the UpDeep project team. He will comment on the results of this project. And then Olli Salmi from the Baltic Sea Co-location Center will talk about the project from the perspective of the EIT raw materials. And in the end, Vesa Nykänen will do some conclusive words, and you'll be able to ask questions using the chat window. So please, I'd like to welcome Saku Vuori. He's the director at the GTK for Science and Innovations. So please, Saku.
Yes, thank you, Maaret. I hope you can hear me.
We can hear you very well.
Okay, thank you. Okay, hello everyone, and welcome to the UpDeep project final seminar of it. And I guess we are living in extraordinary times. I hope you and your family have stayed healthy and that you have avoided the worst troubles. Several organizations have moved into the remote working. It's one of the good ways to try to prevent the growth of infections And perhaps the most interesting case I heard that there was an academic dissertation that was arranged remotely. Surprisingly, the feedback was actually quite positive. And well, this might be related to the fact that the candidate was also successful in his defense. I hope today's remote connections will function well, and the meeting will be good from that point of view. And what comes to the content of this meeting, I have no doubt that the day wouldn't be excellent one. There's a number of distinguished experts and organizations that have been involved in the project. Geus, BRGM, Vienna Technical University, Scandinavia Geopool, VTT, Spinverse, and LTU Business, together with GTK. So even though that we might see decline of mineral exploration investments due to the pandemic, but I'm quite sure that the main fundamentals for long-term material needs remain the same. We will see the recovery of demand for raw materials, and we could perhaps even see return of some parts of the value chains back into Europe. We do have a mineral potential to back it up, and that's one of the reasons why the work of UpDeep is so valuable. And furthermore, the pandemic will cause declining stress to environment, and when the economy is bouncing back, there will be more emphasis on the environmental issues that you are actually addressing in UpDeep project. So I guess you could say that the projects come and go, but I'm hopeful that you have created partnerships and friendships that last beyond the UpDeep project. Besides valuable project outcomes and relationships that will also serve as a basis for building future joint projects, as well as valuable. They are valuable or even more valuable, especially in these exceptional times. I know that we are a bit behind the schedule, so I'm trying to be very short here. And with these words, I wish you great and inspiring meeting for the day. And once again, remember to take care of yourselves and your families. Thank you.
Thank you very much, Saku. Yeah, as Saku mentioned, we're running a little bit late of the schedule, so we will skip the question part for Saku. But if you have some specific questions for him, please address them to saku.vuori@gtk.fi, please. Our next presenter will be Vesa Nykänen from the Rovaniemi Geological Survey as well. So please, Vesa, floor is all yours.
Thank you, Marit, and thank you, Saku, for these welcoming words. So good afternoon, everybody. So today I would like to introduce you this project called UpDeep. This is our almost last day with this project. Not quite. We have almost 1 week to go. And I want to tell you what we have achieved during these 3 years duration of the project. So now it's time to sit back and relax. Upscaling deep buried geochemical exploration techniques into European business was a 3-year upscaling project which was funded by sub-organization of the European Institute of Innovation and Technology, EIT, and EIT raw materials specifically. We are a project consortium of research institutions, a university, well actually 2 universities involved, SME, and we come from 5 different European Union countries. Our project is one of about maybe 10 currently funded exploration projects within EIT raw materials. And I think this is the only one which is specifically focusing on geochemical exploration techniques. The aim of UpDeep project is to commercialize a geochemical exploration service that specializes on surface geochemical techniques. Exploration community in Europe is lacking geochemical mineral exploration techniques which are effective on, especially on poorly exposed terrains or on sites with thick sedimentary cover, or detecting deeply seated mineralizations. And at the same time, they should be applicable for pinpointing drilling targets in environmentally sensitive regions, like on nature conservation areas or in the vicinity of protected habitats. Although regulations for mineral exploration in every EU country are different, overall it may be concluded that getting land access permits for soil and plant sampling is faster than for sampling of mineral sediments done with heavy machinery. Well, at the same, analytics of partial soil leaches and biogeochemical media have proceeded to the level that produced data is rather good quality. So that's a good news. So some background of UpDeep project. We did some interviews as part of the UpDeep feasibility study at the beginning of the project. And these interviews showed that in Europe, quite a few exploration companies are really interested in trying these new techniques. And these companies are actively seeking new methods for exploration. And some of these companies have already been applying these techniques, but the acceptance, how to use so you can think that a real breakthrough for the method would require
Vesa, sinun ääni hävisi.
Okay, it sounds like Vesa got dropped out. And but maybe I'll continue his presentations because I've been the deputy for this project. So if he comes back up, he can continue. So background for the UpDeep project, surface geochemical consulting business is global, but there hasn't been any dedicated European service provider so far. Now, during the project, we found out we have a couple of competitors within Europe, which is nice. But overall, the data collection and interpretation for the data is it is a common issue for all of us who are dealing with the data. And the idea of the project was that we will increase the level of competence and knowledge in Europe related to surface geochemical exploration. So in this project, we had 3 different partners who were related to exploration, geoscience, and geochemistry. GTK was the leading partner. Geus, the Geological Survey for Denmark and Greenland, was part of the project doing some sampling in Greenland and data analysis, as well as the French Geological Survey also had some couple of field sites in France. The feasibility analysis of the business that we have created, and all the marketing and business development has been done by two partners. During the first year of the project, Spinverse was in charge, but after that, LTU Business took over Spinverse's job for the last 2 years of the project. The Vienna Technical University has been doing the statistical compositional data analysis in this project and done some great development in this field. And VTT has been in charge of the data management and software development. So the core of the service that Geopool, who's been presenting the mineral exploration service industry in this project, will be hosting, is based on a software called GEM web tool developed by the VTT. So here are some facts about the UpDeep project. It is an EIT raw materials project and belongs to the category of upscaling. It means that science is developed into a business. The leading organization was TTK, and Vesa Nykänen has been coordinating the project for these past 3 years. We had a total budget for about 2 million euros to do the work. We had a few goals for the project. The main goal was to create a surface geochemical exploration consulting service to Europe, aiming especially at deep exploration, what these material that we've been concentrating on are good at. Our other goal was to promote the geochemical deep exploration concept using the selective and weak leaches for soil horizons and plant tissue. We wanted to facilitate the use of surface geochemistry in exploration companies, especially in Europe and Northern Europe, but also globally. We wanted to provide geochemical methods for greenfield exploration. So these sampling media and techniques are best suited for early stages of exploration. And we wanted to facilitate ore discoveries at depth. We all know that discoveries are getting, and exploration is getting much more difficult and expensive if we want to find deep-lying ores. And this is where the global exploration is directing right now. So these techniques are suitable for discovering ores at depth to a certain level. So the main outcomes are pointed out here on the right-hand side. So we created a surface geochemical consulting service. We made some streamlined sampling and sample preparation protocols. We made a demonstration of standard reference material bank and created a protocol how to make these SRMs, standard reference materials for plants and soil horizons. We created the so-called web tool. We now call it the GEM web tool instead of the UpDeep web tool. And it's a communication tool, data analysis tool, and a data collection tool for exploration data management and analysis. And we also created another web service called UpDeep Online Statistics Tool. And this tool is to share plant and weak leach soil data globally for free of charge for anybody on the planet, and also share your own data. Dissemination and exploitation of the project results. At least 2 research articles have been approved by now, and we have 4 that have been submitted for publication. We had approximately 14 presentations in different scientific conferences related to geology or geochemistry and statistical data analysis. We presented our results and had a booth in 2 different conferences. We hold a short course for 1 day at the Fennoscandian Exploration and Mining Conference 2019 at Levi in Finland, and also had a booth there and talked to a lot of people. We also had a booth and a short course at the PDAC 2020 a few weeks ago in Toronto, Canada. One of our main goals was also to produce some educational results. We have a PhD candidate, Dominika Miksova, at the Vienna University of Technology, and her thesis is just getting ready. She will be submitting it in a few days, and it will be called Combining Absolute and Relative Information in Compositional Surface Geochemical Data Analysis for Mineral Exploration. We did some knowledge transfer and international cooperation to increase our level of competence in the UpDeep group. We have a few young geoscientists and geochemists in the group, and we invited David Herbeline from Herbeline Consulting, Colin Dunn from Colin Dunn Consulting, and Clemens Rayman from NGU to present their current view of surface geochemistry and data analysis for us. So here is an early picture of our UpDeep group. During this seminar, you can also go and explore our project website, which is project.gtk.fi-updeep. Okay. I'm having a hard time of following the chat line right now, so I don't really know what's going on right now, but I don't see any questions. Oh, somebody's asking if these presentation materials will be available after this seminar. Yep. So they will be available. We are recording this seminar, and this presentation will be available too. We don't know the site name yet, but it will definitely be presented somewhere and made available for you guys. As the next speaker, I would like to invite Jens Rönnqvist from the Scandinavian Geopool in Kokkola, Finland, to talk about the surface geochemical consulting business.
Thank you, Marit, and thank you all for joining today. A lot of people online. I'm happy to see that there is a great interest in this in surface geochemical exploration methods. So I'm going to talk a bit about these methods from my point of view, from a consulting point of view, and also from the end users or the exploration company's point of view. Start with this first slide showing. Firstly, I should say that a lot of this material, what I'm presenting, I have got help from Spinverse and LTV Business, who have helped us with making this business model. So this is the value chain we are working in. In the very top part, you can see the value chain of from early stage exploration all the way to mining. And then if you go into more detail, our methods are mostly used in the greenfield or in the very early exploration stage, but it could also be in later part of the exploration work. And then our method, how that fits in, well, there is if you go into details with the value chain within the methods, we have some few important things, like first of all, we have to have an agreement between the consultant and the exploration company. And one important thing here is that you should have a honest discussion. These methods, they are good, but they are not they don't answer all questions. So you should be careful to lift up all these to talk about the expectations and what you can expect from using these methods. And also important is how these methods fit into the overall exploration strategy that the exploration company has. Next thing is the planning. There's a lot of details you have to take into account, and when you do your planning, it's not a linear task. You might have to go back and redo some things what you planned in the initial phase to get a pretty robust plan before you go out to the field. Like there could be example of you having a sample grid that you think would be most efficient, but then you realize that maybe we don't have that sample material, we don't have those plants exactly in those locations. Then you have to go back and redo your grids. Sampling, you have to have good sampling have a good sampling team and well educated, trained into the task they're going to do. You need to think about how to pre-process your samples. You need to communicate with the lab, and you definitely need to have a good QA/QC in place for your survey. And the last things and the most important things is, of course, how to interpret and to report your results. I would like to go back a bit to the uppermost value chain there in the picture. Usually we stop there when we think about that someone starts to mine the resource what we have found. I will come back to that, but please remember that this chain goes on after that. Next thing, the value proposition from these methods. The first thing is, of course, the exploration company, they want to find ore. They want to find a mineral resource. And to do that, they need to have a reliable method to use. So that's number one thing. We need to have a reliable exploration method, and that's what we have developed in this project. Besides that, we also need to be cost efficient, and we need to be able to act quite quickly to do each task as efficiently and quickly as possible. And the things on the top there, low impact. It doesn't really. We can't just think that our task is to find a resource. We also need to think how we are finding that resource. We have to have as low impact on environment as possible. Okay, I'll go through these values in more detail. So this method has a low impact because we don't need any heavy machinery. We can maintain a good, actually, it's not really about maintaining a good social license. This is a very early stage of the exploration. This is where you establish your social license. So starting with a very easy method that will help you to get that social license, which nowadays is so very important. And then to traceability, I mentioned earlier that with this value chain, you should remember about after mining, there is something happening with the resources, with the raw material we explore for after they have been mined out. And I think this is something that will be more important in future. And this is something I have now understand when talking to Spinverse and L2 business. that actually, of course, main thing is to find a resource, but actually the way you did find your resource might have impact on the value of that resource in future. Because nowadays we talk a lot about that we have to trace back where all the raw materials are coming from, and are they from projects that are in good standing? Do they have a social license? And has has good methods been used to find those? Also, what comes with this low impact is that it's much easier to get a permit to do this lightweight work. And then the important thing about reliability, what we have done in this project, we have developed a QA/QC protocol. We'll talk more about these in details later on in other presentations. We have produced standard reference material. Pertti will talk about that after this presentation. And this data, it's really, there's a lot you can do with this data when combining it with other data layers. And I think that's something that hasn't been done that much yet. So there's a huge potential there. And one of our main tasks is to find drill targets and to prioritize where is the best place to drill. Also, in the GemWeb tool, we have a system how to document everything. We can use more sophisticated statistical analysis methods, which were not available earlier. And we also have this online statistical tool available on the web. Then about cost efficiency and the significance of having a quick process. Well, first of all, the sampling is fairly quick. You can collect quite many samples in a day. And one really nice thing is in some countries you can do these methods before you have an exploration license in place. And that's really a huge benefit. You can see from the graph there in the picture that if you can start to work 2 years before you even have to put in a exploration license, you won't have any land fees cost. And of course, these are different in different jurisdictions, but anyhow, and also the benefit with this, if you start early, maybe you can decrease your exploration permit area, and that will then reduce the costs in future. So I just made an example here of reducing the exploration permit by 30%, and the black figures are if you didn't reduce it, and the green if you did. And also you are, by starting early, you can do your drilling earlier. You find your drill targets earlier, and so time is money. Okay, then about our service. So what am I trying to promote here? You can buy a full service package from us, from everything from the planning phase all the way to reporting, or you can just ask us to do individual tasks. You can ask for help, what samples, what to sample, which sample media, which analytical methods to use. About the sampling, we can train your personnel to do the sampling if you don't want us to do it. You can ask us what parameters is wise to collect in the field. Yeah, and a lot of practical details what you need to know. Also about the lab, we don't have an own lab. We will use labs that normally are used. But what we can help with is what you need to communicate with the lab. There are some important things that you need to communicate with the lab, and you need to have an understanding what the lab is capable of deliver. And then the QA/QC, we'll talk more about that. It's a really nice thing what we have developed in the GEM web tool, and also the interpretation part. So from this project, what has myself as a consultant, what have I learned from this? We have developed really nice workflows, both for how to plan the surveys, how to do the sampling, the QA/QC, and also the interpretation. And all these workflows are channeled through the web tool, and in the final stage in the reports. And a good thing also is that we have done some case studies in this project, so those has helped us a lot to understand how to use these methods in the best way. And what Saku also said in his words in the beginning, yes, we have developed a very good network in this project. Really, we have now good connection to experts from many areas. Sorry about some spelling mistakes there in the heading. I can see now. Okay, so, just a few bullet points. What's important? If you want to do a survey like this, it's best to do the sampling during the summer or in the beginning of the summer, especially if you're going to sample plants. So you need to start the planning in early in the year. You should think about the QA/QC, what's needed from you, because it will have an effect on the budget. You need to communicate with the laboratory. You need to have a well-trained field crew. There could be things that you can't control, like the weather has some effect on when you can sample, and the results you will get pretty soon. It's more dependent on the laboratory how fast what their turnaround is. And so I really encourage you to use the knowledge that we have developed in this project, and you can do that by reading the presentations that will be available here, or I really encourage you to contact any of us in the team, and we will be really happy to help you in any ways. Thank you very much. I can see one question there. But
yeah, Jens, please answer these questions. Are these surveys allowed in Finland and Sweden before the exploration permit is acquired?
Yes, they are. They are in Finland. In Sweden, you need to have I think you need to have a work plan in place in Sweden. I think any systematic collection of data would need that, but it's a bit of a gray zone there. If you have a very large area, the sample points are widely spread, then yeah, it's not. I don't have a clear answer to that, but it depends a bit on the area.
Okay, I think we are about a couple of minutes late from the schedule now, so we will continue. Thank you very much, Jens, for the great presentation from the practical point of view and from the business point of view. And will continue to Pertti Sarala. Pertti will talk today about the standard reference material bank that we developed in this project. And I'm really hoping Pertti's microphone will work. Can you say something, Pertti, please?
Yes, good afternoon, everybody. Can you hear me?
Yes, we can hear you very well.
Okay,
Please continue.
Okay, yes, so good afternoon. So I will talk about one concrete result of this UpDeep project, so standard reference material bank for topsoil and plant geochemistry in mineral exploration. And so just a few words about background. So surface geochemical exploration or surface geochemistry, we are practically dealing with mobile metal ion theory, where we have mineralization in the bedrock, and due to oxidation and bacterial work, ions have been released from those mineralizations, and by the different processes, they are migration through the bedrock surface and transported cover to the topsoil and even the snow here in northern hemisphere, where we have snow cover, and accumulated on topsoil of mineral and organic soils. And there we can collect those samples from topsoil or plant and even plants or even snow, which is very environment friendly way and very low impact sampling methods, easy and quick way to collect samples. And then we can use many commercial analytical methods for analyzing element concentrations from different materials. And so background for why we are doing this kind of reference material bank development here in UpDeep project was that earlier we found that there wasn't any reference material available in Europe for this kind of research. There are some companies, for example in Canada, who are providing this kind of material, and particularly certificate reference material, but those sample materials are very expensive and not very comparable to European environmental situation. And why we are using standard reference material, it's a cheaper way to produce this kind of reference material, and they are particularly good for small projects because it's not so expensive to use during exploration projects. And in this UpDeep project, we demonstrate how to do and how to prepare material for this kind of sample bank. So there are practical sampling procedures we have developed and demonstrated, then pre-processing of sample materials, and then analytical test procedures for producing that geochemical standard materials. And for demonstrating, we collected samples from northern Finland, 2 targets related to gold exploration, and in that area we have typical glacial till cover, those places, and known mineralizations, and we collected for soils A8 and B horizon samples, and then made subsamples for analysis. And here you can see what kind of environment we have here in northern Finland. So typical potsoil soil profiles, and we collected A8 samples, which is seen on west. This photos as a black layer on top of mineral soil, and then B horizon samples, that is the brown one, material on right side photos. And for plant sampling, we used Norway spruce foliage and bark, and Scots pine bark, and then common foliage. And you can see how those materials have been collected, those photos. And then sample processing, I'm not going in detail about that, but for different materials we used certain procedures to process samples before sending subsamples to geochemical laboratories. So, for example, in this A8 horizon, we did homogenization in the field, and then made subsamples, a small amount of them, and then part was sent to the laboratory for analytical testing, and then rest have been stored for later customer use. And same type of procedures for B horizon samples, two different way homogenization in the field in the first stage, and then another case we did homogenization and also sieving to minus 180 microns before sending laboratory. And then after all those processes, we have a small bank for demonstrating this bank process for soil samples, and then for plant samples we had a little bit different procedure. So before doing anything, so plant samples should be dried, and then for juniper and spruce samples, twig and needle material should be separated or sorted by hand. And then both twig and needle materials and bark material was built at the GTK's Intec laboratory, and part of the material was ashed at Labtium before sending subsamples to Geochemical laboratory, and other part was just homogenized and then subsamples once again analyzed in Geochemical laboratories. And here you can see kind of bulk samples on left side stored as bottles or plastic bags, and then on right side subsamples, small subsamples ready for delivering to customers. And here you can see what kind of chemical analysis we have used in this project. So we chose 3 different methods for A8 horizon, couple of weak accuracy Regression method and sodium pyrophosphate, and then for B-horizon, sodium pyrophosphate and ionic leach techniques. And for plant samples, it's typical to use aqueous or nitrogen acids. And we have done comparison in different laboratories, just to demonstrate how to progress with normal bank samples. And then all the materials and procedures have been reported, or kind of certificates. They are available for each sample material type, and those reports include descriptions of materials, how they have been pre-processed, and what kind of dissolution have been used, and final results, and also some statistical, basic statistical information is available. And those certificates are delivered to customer with sample material. So here is some examples of graphs that is available from those reports. And how that material is then planned to use. So customer can buy some sample material and then place those materials, for example, 5% of their normal sample set they have collected, and then by that way they can then monitor laboratory accuracy and also laboratory precision and see if there are any trends during the analytical phase of samples. And for example, later it's easy to see if there is any trending during analytical phase laboratory that can disturb results, or if there is variation, then customer can contact laboratory and ask them to reanalyze samples if needed. So what we are offering here is a set of samples that we can ship to customer. Current sample bank is very small, but it's easy to update and also add new sample types if customers are needed. Then expertise to prepare and sample material for client, and then also we have some facilities that can be used for processing sample materials, like in TDK's Mintech laboratory. And if you are interested and need some materials, please contact Jens and Marit, and you can see their email addresses there. So that was all. Thank you.
Thank you very much, Pertti. We don't seem to have any questions right now for Pertti, and we are right on schedule, so I would suggest that we move forward to keep the schedule. So thank you very much, Pertti, again, and you can always email Pertti too with pertti.sarala@gtk.fi if you have further questions. So now I would like to invite Jeremy Melleton from BRGM, Orléans, France, to talk about the Streamline surface geochemical sampling protocol. So please, Jeremy, are you online?
I'm online. Thank you, Marit. Good morning, good afternoon, everybody. So the aim of this presentation is to give some clue for the preparation of surface geochemical sampling protocol. And to help for an optimized sampling and an optimization of the sample preparation procedure. And of course, to give some clues for the preparation of checklists for samplers. So the first important question, of course, is what do we get to sample, where and how? And the first steps to answer to this question is, of course, to make a collection of all the data available and about the targets. So what is the geology, the geography, river location, and different kind of land use, and if you have some geophysics data available, data from former prospects, and so on. And one very important thing for the surface geochemical methods is, of course, that you need to be very careful with all things related to anthropogenetic activities, and especially land use, all the industrial activities that is going on, but also past industrial activities. And you can use also for this kind of information all the aerial photographies, for example, national database, and so on. One important thing, of course, is also the ownerships, because in most of European countries, you need to get the authorization from landowners to get on field. So here, the example on the down of the slide, you can see some available data coming for the preparation of a sampling campaign in the Vendéan antimony district in France. Of course, the geological map, you have the Corinne land cover that gave a large idea of what are the land use in the area between forest, cultivated fields, and so on. And you have also the ownerships that in France it's quite a tricky question, because many fields and many different ownerships, so can be kind of time consuming to get authorization from everyone to have access to the field. And also aerial photography will help, and especially in this case we can see some area with trees, and to prepare some geochemical sampling campaign, it's very useful. So the second question, where to sample? There are different ways to approach this question. In the framework of greenfield exploration, of course, you will work in a large area using grid sampling, and you can all place in the same distance every samples, but you can also use random sampling. It depends what you want to get in this case. So of course it's more regional. You have a Bruckner signal, but the resolution of your survey is of course lower. For our case, of course, you have already some data available, and you want to target some specific geological features. You have, for instance, some geophysics that give you interesting results, and you want to have an idea of what is going on. So in this case, you can plan for higher density for this target, and in this case, it's of course cost and time reducing, and you can prepare high resolution. You will reach high resolution, but it requires all this prior knowledge. And of course, it's always better to have more sample in the area you think could give an anomaly, and so better to place a bit more samples in this area. So now how? So Pertti exposed already the principle of the surface geochemical methods that are based on the mobile ions theory. So when you will look for vegetation, the first thing is to select one or more species that will be available at all stations, because what you are looking for, of course, is gradients between different analyses, and to find some anomalies. So you need that these species are broadly available. For the choice of the plant species, of course, it's better to target large root systems like trees, because you can see in the figure the schematic, it's the roots are going much deeper and much larger. It's integrating the signal in a larger area than if you are going to take some annual plants or herbs and so on. Then after, you have to make the choice of the plant part you will sample, if they are the leaves, twigs. But the most important in this case is to be consistent. And so if you choose to sample the leaves or the twigs, always same thickness. Bark also can be sampled, but always you need to have to be consistent. So for trees, always take the same age of trees, so same diameter. It's also always better, if possible, to sample multiple plants inside the sample station and not take everything on one specimen. Depending on the analytical methods you want, and always better to take a look of what the laboratory require. You will take something between 50 and 200 grams for one sample. For the preparation, there are several possibilities. You can go on for dry pulp, but you can also ash the sample. And this is also important, and it's relevant to the elements you are looking for. Keep always in mind that some elements are very volatile, and so that, for instance, if you take antimony, for example, up to 40-50 degrees, it's evaporating. So if you ash your sample before analysis, you have the risk that you lose your signal. So for soil sampling, the same. The importance is to be consistent. So whatever classification you will use, international, national, for the different soil origin inside the profile, always be consistent. So you always have to take the same origin if you want to make comparison, of course. So for surface geochemistry, we will target or the AAU microregion, AH, just under the humus, or you will go for the bioregion, that is the accumulation horizon. Or for some kind of superficial geochemistry methods, you will go for constant depth, especially if soil horizons are poorly developed. If possible, when you sample soil, it is always better to keep distance to anthropogenic contaminations like roads, building, agricultural activities, but it's not always possible. Especially in Western Europe. It is always better to make pH measurements of soil directly on field or just after. And one sample of soil is between 200 and 300 grams. So for the equipment, it always have to be adapted to the field you will go for prospecting, but of course some things are you cannot escape to take with you. For instance, shovel. So shovel always better to always needed to take something without any painting, because you could have some contamination. Gloves are important, so always prepare nicely also the kind of containers you will use to put your samples, or cotton bags or plastic bags. And after, for plant collection, sizers or shears are preferably better in ceramic. It can be always nice to have with you a portable weight. It's allowed to be sure you collected enough material when you are, and so on. More and more we use GPS and tablets with field app that or directly cell phone to collect directly the information of your collection digitally. So for the field preparation, the samples need to be quite fastly prepared at the first step. One of the first questions for vegetation is to wash or not to wash. It's an important question, especially if you have dust production in the area. If you have, for example, quarries and mining activities, or just road or that are passing near, it could be better to wash your sample. But always better to dry samples as soon as possible. For some application, you can go for 70 degrees for 24 hours. But again, it's better to pay attention because some elements are very volatile. If you cannot if you cannot dry your sample quickly, better to leave them inside the cloth bag and in a well ventilated. And if you can let them under sun, it's a good solution. For soil, always better also to dry the samples as soon as possible. So I already said, quite nice to make measurement of pH in the soil or at the sample station or back in the camp. You can also make a second measurement adding a weak acid or vinegar in the solution to make the test of the buffer capacity. And if possible, also nice to test the resistivity for the redox conditions. Also nice to make on-field soil moisture measurements, and you can use for this TDR probe or this kind of device. So always better to think at the first step about the QA/QC procedure. So, and especially for field, about field duplicates. The field duplicates are needed to test the combined effect of the real geochemical variation, but also on the sampling error or the sample preparation error. So always better to think about 5 to 10% of sample day station where you will collect field duplicates. And since it's always better also to plan already lab duplicates, in this case to investigate lab procedure uncertainties, it's always better to double the amount of the field duplicates. So you have a picture on the right of the slide. You can see on the left is the regular sample. On the right you have the duplicate sample with double amount. So there are many data to collect on field during the sampling, and especially a lot of field observation related to the environment of sampling, and with a special target to possible sources of contamination. So everything that will help you to interpret your data. So you have on the right, for instance, example of sampling sheets that has been used for the sampling in France, and so we take information, of course, about the sampler. We take information about the environment, so the slope, the kind of vegetation, the lithology. We make a description of the sampled horizons, color, deepness, thickness, if there are the presence of organic materials, the presence of roots, which kind of course elements you can find on it, and if it's humid or not. A bit an idea of the composition between sand, silt or clay, but always also better to try to find a way to be coherent in the way you are taking this information. So maybe only one person feeling or really agree before, or what are the conditions to describe what you want to keep as information. And of course, so all the sources of possible contamination are important: road, agricultural practice, if there are waste or other, if there is a distance. And the same for plants, so you can take all information about the kind of environment, if you are in a wild forest, if you are in a cultivated forest, fields, and so on. So you will have presentation later this afternoon on the UpDeep web tool, but you will see that it's quite nice to prepare the sampling campaign. So you will see that you can prepare the list of samples. So first, to go on field, you will export this list of sample, and all these variables that you can observe, you can save it inside the standard log sheet, and then you will have the possibility to upload all this information. And yeah. So then the last part after field will be to upload everything in the UpDeep web tool. And I finish with my presentation, so if there are any questions.
Thank you very much, Jeremy. I don't see any questions here. Maybe I can ask one myself before we go forward. We have 1 minute left. So when you go to a field site, do you go there with all your gear already, with a plan, or do you think it's better to go and visit it beforehand?
Yeah, of course. It's always better to make an orientation survey before, especially to have an idea of the plant species that are present. You can also make in few places investigation on the soil profile, of course, before to go on field for the campaign. So it will help to decipher with a species, which species you will sample and which horizon you will sample.
Okay, thank you very much, Jeremy. If you have any more questions for Jeremy, you can email them to j.middleton@brgm.fr. And I would suggest we go on with the presentations, and we move to Peter. Peter Filzmoser is a professor at the Vienna University of Technology in Vienna, Austria. And today he'll be talking about some statistical data analysis that are specific for the surface geochemical data. So Peter, can you say something? Okay, please go on.
Okay, now it should work. Can you hear me now?
Very good. Yes, very well.
Okay,
thank you.
great.
Go on.
Thank you very much. Yeah, good afternoon from my home office in Austria. We also got some snow today morning. Quite strange for this time of the year in Austria. So in the title it says that it should be a statistical data analysis of geochemical data, including case studies from Finland, Greenland, and France. I will not include all these case studies, otherwise the presentation would last too long. So this is based on joint work with my PhD student Dominika, and as Marit already mentioned, she will hopefully finish very soon, so the plan is to submit the thesis by the beginning of next week. This work which we did in this project is also a bit driven from this PhD thesis. So a thesis in mathematics statistics should not be just well, just data analysis, but we should also develop new methods. So method development was also somehow in focus. Here in this presentation, I will mention the different steps that we somehow joined in this project for starting from data collection to data quality control, how to represent information, how to do data pre-processing, then finally analyzing data, and well, I will end with some conclusions. Well, this is not just true for geochemical data. It makes usually not much sense just to collect information as much as possible, but and to think about what to do later on with all this information. I think it's always important to talk to specialists in the field in order to know which information is important and to collect information targeted. So that's quite crucial. In our world of big data, it turns out that not often in this big amount of data there's a lot of useful data for the question. So therefore, sampling design is quite important in any geochemical study. And there are different considerations. The geological considerations are quite crucial. So if we do mineral exploration, is there some pre-knowledge already available about some mineralized areas which we are targeting? Are there even in the targeted area, have there been some pre-studies? Are there even some geochemical data available or geophysics data available? Then it is quite important, what are we expecting as a geological structure of the mineralization, and depending on the structure, line or grid sampling might be useful. Of course, there would be much more to tell. I'm just mentioning the most important things. Well, there are some practical considerations as well. So, as statisticians, we always would like to have as many observations as possible, but unfortunately, there are budget constraints which usually limit the number of samples. So there's always some kind of trade-off or compromise. It is important that the samples are placed on the expected target, but also on the background. Statistics lives from variability. If there is no variability, we have no statistical outcomes. And it is also not quite clear where to take samples from. So the sample medium is quite important. Geochemists usually have some idea what to take as a medium. Later on, I will also show some statistical approaches, which sample media could be promising. Okay, now to the statistical considerations. If you go to the literature in statistics related to sampling, to geochemical sampling, there is in fact not too much available, or at least not too much which is really which can really guide you through this procedure from a practical perspective, because many things which you find are more from a theoretical point of view, and practice unfortunately looks a bit different. So some experiences which we made in this project is that ideally there should be at least 3 samples placed on top of the mineralizations, if you have an idea of their locations, and at least 30 samples should be made available. And of course, if you have more, then this is better. It might be cheaper to do line sampling rather than grid sampling, because then you might get out more statistical information if the samples are placed along a linear transect. But it is important that the linear transects cross the target, the expected target, and if it is possible, one could also use several parallel, for example, linear transects. If there is some pre-knowledge or pre-measurements available, then one could also consult geostatistical methods like diagram estimation kriging in order to predict useful locations where to place these samples. Of course, there would be much more to tell, so these are the, well, I would say, essential things that should be considered from a statistical perspective. Now, once we have placed the samples, once we have taken samples, there's a lot to consider for data quality issues. So QA/QC, quality assurance and quality control, is a very crucial step in order to get reliable results. There is one basic problem, the data uncertainty, which is basically accuracy versus precision. The accuracy is the trueness of the measurement results. So there could be some systematic errors, and they would lead to a bias of the measurements. The precision is the other important thing. If you repeat sampling, would you get the same results or similar results? So how good is the repeatability of the results? And if you improve precision, both precision and trueness, then you could end up with somehow reliable information, reliable for the statistical analysis and for the conclusions later on. So for this QA/QC analysis, what we did in our sampling procedures was we took routine samples. So those are the regular samples somehow that are collected in order to investigate for the occurrence of mineralizations. We also took field samples, so in order to monitor uncertainty. We took laboratory duplicates in order to monitor precision from the laboratory. There have been blank samples in order to identify if there is contamination in the lab, and there were also reference samples in order to monitor the precision, accuracy, and also possible trends which can appear in the lab measurements. So all these samples should now be taken into account in a QA/QC procedure. And for this procedure, we identified 6 different steps, and this is also implemented in our GEM web tool. So the main task basically is look at your data. Not just compute one number, but look at the data, but do this appropriately. That means we should prepare the data in order to get maximum knowledge about data quality. For example, in QA/QC 0, we produce data overview, tables, and plots, all revealing somehow statistical information and an idea about the data distributions. So like box plot, CDF plots, and things like that, where you can see different aspects of data distribution. QA/QC 1 refers to the process quality. For example, in the analysis sequence, is there some pattern, some temporal pattern? If there is something, then we should be concerned somehow. QA/QC 2, the accuracy. Here we have reference samples, and consider these reference samples versus the analysis sequence. In the step 3, we have laboratory contamination, so we compare routine and blank samples. In step 4, the field samples enter, so the field duplicates are taken to identify the field precision. And in step 5, we compare routine samples with lab duplicates in order to monitor analytical precision. I could show now many plots for all these different steps. I'm just showing one plot for the last step, analytical precision, referring to lab duplicates. And here we can see from a project carried out by Geus in Greenland. So in the frame of the UpDeep project, they did sampling there. And here we have from some samples the QAQC5 procedure for 2 elements here. So what we plot is for these lab duplicates, we compute the mean, that's the horizontal axis, and the vertical axis is the absolute difference of the duplicates divided by the mean of these duplicates. So here we can see some horizontal lines like the 10%, the 20% line. Usually you should not exceed much more than the 20% line. Here this is still quite okay. Usually what you would expect that with lower mean, so lower concentration values, uncertainty gets higher, and then you would exceed clearly the 20% or even the 50% boundary. So this is one of the plots we produce for every element, for every sample medium, and then you can get a quite good idea about the laboratory precision. So this was about data quality. The next step would be data pre-processing. Again, there would be many issues to be mentioned. One important issue is the problem of censoring. So we have usually some detection limit issues because measurements or the measurement devices can only measure from a certain concentration on and also up to a certain level of the concentrations. So there will be usually values below a lower or above an upper detection limit. There are different procedures to, well, somehow estimate values below the lower detection limit, but we've hardly found any procedure to estimate values exceeding an upper detection limit, and this has been developed in the UpDeep project. So what people traditionally do is if there are values above an upper detection limit, I think this appears often in ashed samples with some specific elements. So if this occurs, then a pragmatic approach would be simply set those values equal to 1.2 times this upper detection limit. This might not be quite useful from a statistical point of view because you introduce many constant values, and this could have some effect on later on in the statistical analysis. So what we did is we incorporate the whole composition, so the multivariate information, also including other element concentrations, in a regression framework to estimate these values exceeding the upper detection limit. I'm not going into many technical details here, but what you probably recognized is the word composition. And I think this is quite crucial because geochemical data are in fact compositional data. So compositional data, there is a question, what is about the percentage of censored data? Well, this really depends on the measurement. So often you could have just 5% upper detection limit values. You could have even much more. In the paper which we produced here, we did simulation experiments with a huge range of sensoring, starting from a very small up to a very big one, so even exceeding 50%. And then you can see how the method works. Of course, the more sensoring, the more difficult it is to estimate reliably those values. But coming back to compositional data, if you make use of the multivariate information, you could again get higher precision. So compositional data analysis means that not the absolute concentration values are of major interest, but it's more relative information which is of interest. That means we are interested in ratios between pairs of elements, or better, in log ratios for some reason, for some symmetry reasons, for example. And those log ratios of element pairs, they would be the building blocks, so to say, for a compositional data analysis. I will go back to this later on a bit in more detail. So this is just one plot from this paper which we published to estimate values above the upper detection limit. What you can see here is the top row refers to phosphorus measurements, the bottom row to zinc. Here we had upper detection limit problems, but the lab also provided unofficially values exceeding this upper detection limit. So the horizontal axis, they are referring to the actually measured values or reported, unofficially reported values, and the vertical axis refer to the estimated values depending on the method we are using. So in the left column, we see this primitive or simple method where we just place values at 1.2 times the upper detection limit. I think it's 1.2. So what we produce is many constant values, and that is not clever to do from a statistical perspective. The next two columns refer to our regression-based method, where the whole composition was taken, so also the other elements with reliable data quality, in order to estimate values above the upper detection limit. So we can see there is a classical method, the middle column, and the robust method, the right-hand column, depending on the type of regression methods which we considered. Classical refers to least squares regression, robust to a robust regression method, which could cope also with outliers in the data. So we also implemented this in an R package. I will at the end refer to the paper where we published this thing. So data pre-processing means that there are some steps like this detection limit issue where you could still improve data quality a bit for the final statistical analysis. Good. A first step might be to look at correlations, so to do correlation analysis. I'm showing here some results from the data I mentioned already, which have been taken from the south of Greenland. You can see a plot here, and there have been 3 parallel transects crossing mineralized areas. So it was known that there have been deposits of iron, titanium, vanadium. The green points, it's probably hard to see, those are the potential locations of these mineralizations. Samples have been taken from soil, but also from 2 plant species. Okay, now we do correlation analysis. The first question would be how to do that. Well, you could just take classical correlations of the concentration data. This is done for and petromnicrum samples. In the upper left plot, uranium versus calcium. The correlation is 0.24, so rather weak. If you would do that in a compositional way, then we get this plot in the upper right corner. So here I mentioned that the building blocks for a CODA analysis are pairwise log ratios. Well, there is this CLR transformation, which is in fact aggregating or averaging all pairwise log ratios from uranium and from calcium, and this refers to the CLR transformed variables. So if you look at the CLR transformed variables and their correlation, it changes to minus 0.65. So there's a huge change. In fact, this is the most dramatic change here. The bottom row shows also a very huge change, but I should honestly say that not all the correlations change so strongly. So if we look at a heat map of all the pairwise correlations, you can see the elements are listed here in the rows and columns, and the crossings, so each rectangular shows the correlation of that pair color-coded. And the color coding is, the color key is on top left, with negative correlations in blue and positive in red. Rows and columns are rearranged in order to see a nice pattern, and we can see if we used the concentration data, more or less everything is intercorrelated. If you use log transformed data, and this is what in geochemistry people often do, it does not change too much. So again, many positive correlations, many intercorrelations. If you use CLR transformation first, then the picture changes quite a lot. We can see two or several blocks, in fact, of correlated variables. And those blocks might refer to underlying processes in this area. So geochemists could hopefully then interpret these blocks or the elements joining one block. So the message is, even for correlation analysis, compositional data analysis makes a lot of sense. Here, just one PCA with this data set from Greenland. That's a PCA of the data from the plant species Empetrum nigrum. We can see this is the CLR transformed PCA. We can see gold is sticking out here quite strongly. The configuration of this in this biplot can now be interpreted by geochemists. And if we look just at the scores of the first principal component, so this is the map again of this project area. This is the map of scores of PC1. Again, PC1 is dominated by gold, molybdenum, manganese, cesium, and so on. Then you can see this distribution of the scores. And probably this refers to some process which is underlying this element combination. So again, this is just an example what you can do or how you can prepare results from a CODA perspective. One definitely important step in the project was identify mineralization. So we tried to develop a procedure for identifying mineralization. This procedure is different, slightly different, if you have samples on a linear transect, so line sampling, or if you have samples on a grid in the plan, so grid sampling. The basic idea is, however, the same. What we try to consider is log ratios of element pairs, like this log of arsenic divided by vanadium. And the idea is that, well, one of these pairs could be stable in the project area and the other element could vary with the mineralized zones, and both elements are measured somehow with uncertainties. But if you divide them, you could probably reduce uncertainty. And this is the idea for a log ratio. The log makes it independent if you used one element as numerator or denominator, just the sign changes. Sorry, then I try to get to the question. ILR transformation. Well, ILR, you could do PCA based on ILR transformed data. You could go back then to the biplot, which is usually presented in CLR. CLR is basically easier to handle and to interpret, but I'm aware that there are many ILR transformations which are used as well. There are some R functions for correlation analysis. We implemented those in the package ROB compositions. So our interest in this procedure to identify mineralization is in log ratio with a strong local change, strong local variability. And that means we try to compute a measure of local variability, which we refer to as curvature. Here I have some examples. That's for the univariate case. So if the samples are taken on a line, the horizontal axis refers to the distance between the observations. So in that case, that's normalized in 0, 1. And the vertical axis to the concentrations of different elements. And we can see the original data points, for example, in the upper left corner, we can see two quite strong outliers. Now, if we would do would build log ratios of these 30 or 40 measurement points, there would be a lot of uncertainty left. So instead, what we do is we try to fit those data by a smooth curve, which you can see in these plots, and the fit should also somehow be attracted by those strong signals, strong concentration values. This is, by the way, the same in the two-dimensional case. So what we try to do is we take GAM fits, generalized additive models, which produce smooth curves, and where the smoothness can also be regulated quite conveniently with a tuning parameter. So once we have these smooth fits, we could produce artificial data points by just taking a grid on the horizontal axis and taking as artificial concentration values just the values on the smooth fit. And with those values, we build log ratios. And this is what you can see here in this upper row. These lines are the log ratios of the smooth fits. The points would be the log ratios of the original data points. So we can see that the signal seems to appear much better with the GAM log ratio fits. And then the bottom row refers to the curvature, which is essentially the second derivative of the top row smooth fits. There is a horizontal dashed line, which is some kind of threshold, and if the curvature exceeds this threshold, then this refers to an abrupt change in the signal. So a strong curvature, probably referring to mineralization. Details are in papers, which I will refer later on. Okay, now we try to automatically identify element pairs which lead to high curvature. I should also say that there is a measurement of high curvature, so these peaks exceeding the threshold, they are somehow aggregated by a measure which we call Z value. And this Z value can be used now to rank element pairs and to automatically identify promising log ratios. Here we can see log ratios. So the rows refers to the numerator, the columns to the denominator of the log ratio, and it seems that molybdenum as numerator or denominator combined with almost any other element is a promising log ratio to indicate mineralization. Here the left picture is for Empedrum nigrum, the right picture is for the soil samples where you have other elements involved as well. So the darker blue, the higher the C value. And we have extended this procedure also to the two-dimensional case. This is again for this Greenland data where you have 3 parallel lines samples, so we can treat them as a grid sample and interpolate, spatially interpolate the concentration values with gum fits. So the left one is for iron, the right one for titanium, and then again build log ratios, pairwise log ratios, compute the C value as a curvature measure, and then rank the promising pairs of log ratios. And here you can see the top 15 ranked pairs for salix, for empedrum, and for soil, together with the C values. So we would then look at those pairs in order to see which locations could be of interest for exploration. So here we can, for example, see 2 highly ranked log ratios, calcium scandium on the left and aluminium calcium on the right hand side. What is also interesting, these C values of different sample materials can be compared. They are somehow scaled quantities. And now we could compare the ranked C values across the different sample media. For example, the red line refers to the ranked C values of empedrum, and the other lines are the ranked C values of salix and soil. And now you can see which sample materials lead to high C values, and this could give information about which material is most useful and promising for the exploration task. Okay, I'm coming to the conclusions right on time. So what we have done in this project from a statistical perspective was exciting, very exciting, especially because we could work together with many specialists, geochemists, but also practitioners and people who aim at selling these developments. So sample design is quite important, and we concluded that just from a statistical viewpoint, it makes no sense. You need to collaborate with people from geochemistry in order to plan sampling design. Data collection is quite important, but once you collected your data, they should be arranged in a structured way. And we have this GEM web tool, which is an ideal tool to do data collection. Then we have this QA/QC, again with GEM, with the GEM web tool. All these procedures that we follow in QA/QC come out automatically once you have arranged the data appropriately. Data pre-processing can improve data quality, which is important later on for the analysis. For the analysis, we should consider the compositional nature of the data. This is basically in all steps of the analysis. And then we have introduced a method to identify mineralization. We should not blindly trust this method, but always probably combine with other procedures, and on top of that, ask the geochemists for the opinion, and depending on their experience, they could say this is indeed promising or this might be a bit strange. Here I just list some papers where we have published these methods. Some are just submitted papers, so we have published them in archive. the last one will be on archives very soon. Okay, thank you very much.
Thank you very much, Peter, for this really interesting, in-depth presentation about the statistical data analysis on surface geochemistry. So I have a question. You know, in most cases, you want to use compositional data analysis when you're dealing with any kind of a geochemical data. But are there any cases that you wouldn't need to do it when you're working with geochemical data?
Yes, there are cases. Quality control is such a case, because what you get from the lab are concentration data. So here, probably we should, as a first step, look at the concentration data reported by the lab and not start immediately with some compositional data aspect.
Okay, thank you. And I have another question regarding the QA/QC. You've been working now with the surface geochemical data for quite a few years. So what do you think is the minimum level of QA/QC from the statistical point of view that you had to take when you're running a surface geochemical survey?
Well, the minimum level is you should get some idea what could happen in the field and what could happen in the lab. So, well, it makes no sense if the variability is so huge for some elements on neighboring sample locations, then you should somehow be able to quantify this variability, and therefore doing a QA/QC referring to field and lab precision is, I think, the minimum you need to do. This also helps to select elements finally for the analysis. Remember that all these compositional data analysis make direct use of the multivariate information, so it is quite important which elements enter this compositional data analysis, and this can be guided by an appropriate QA/QC procedure.
Thanks. I think you already answered all the questions in the chat box. So for that reason, I would suggest that we're going to have an extended coffee break here. So we'll be back at 2:30, but I would advise that people still stay online, don't log out. So stay online, and the presenter, just mute your microphones. And yes, I will just say one more thing. One of the outcomes of this project was the UpDeep online statistics tool. So I attached the link here in this slide. Copy paste that, or write the link into your browser and go and explore it during the break we're having now.
Continue our program with the second session. I hope you were able to stretch your legs. And our next talk will be given by Maarit Middleton. And the title of the talk is GEM Web Tool for Geochemical Data Collection, Management and Analysis. So, Maarit.
Sure. Thank you very much. Okay, so just before the break, Peter was presenting about the statistical techniques. Some of them are included in this GEM web tool that we programmed in this UpDeep project. The idea for the GEM web tool came actually from the expertise that VTT has. They have developed many of these similar kinds of software before that are all run in the web. So basically the software is sitting on a server and people access it through any kind of a common browser. So this GEM web tool, it is for geochemical data collection, management analysis, and the current version only includes the surface geochemical material, and more specifically, it only includes the soil partial extraction data and the related metadata, and the plant biogeochemical data. So the GemWeb tool, it is basically made to facilitate communication between an exploration geologist, a geochemical consultant, and the field crew. So all information and data is in digital format in all stages, and it is stored in a database on the server. So the advantages of this is that there's no files floating around in emails nor on people's hard drives. So if the companies have some data that is confidential, it'll be safely stored on the server in the database of the web tool. The progress can be followed by the customer all the time. So the customer has certain rights to go and access all stages of the exploration phases. So they can go and see any day or any time what is going on and how far the project has been proceeded. So in most cases, the GemWeb tool will be installed and running on the consultant's server, but it is not a must. Anybody in the future can purchase this software and put it on their own server. Let's say you have big exploration companies who run these projects like every year or several a year. They might want to have sitting one of these web tools on their own server and use it for internal purposes. For internal purposes to communicate between the exploration geochemist and the exploration group. So every project member is given a personal username and a password. So it is a secure system behind username and passwords. It can be accessed with any common browsers. So there's no installation required by the user. Like I'll repeat what I said before. It is specific for soils, especially for partial extractions and plant data right now. And it is definitely not another GIS program, and it's definitely not another geochemical analysis program. It is very specific for this certain type of data. So you guys probably already know that certain steps are taken in every geochemical survey, and the same applies to a surface geochemical survey. So in a business case, we have a customer who orders some kind of a survey or part of it, and we have a consulting company that is providing it. They do a contract in between them, and they exchange information between them to make a sampling plan. And I want to emphasize that in this project, we made just technical solutions. So the interaction that is required and the information exchange between the customer and the consulting company, it is crucial still. This software is not going to replace it, but instead, we're hoping that it would facilitate the interaction between the customer and consulting company. You cannot assume that the consulting company knows it all. The customer has to provide a lot of background data for the consulting company, and in between the two of them, they can make joint decisions how to do and run the whole project after that. Then you can proceed finally to sampling. After the sampling is finished, you'd have to do some sample pre-processing. For example, plants, you have to dry them, and you have to separate the needles and the leaves from the twigs. So this is considered as sample pre-processing. After that, samples are being sent to laboratory analysis, and you can use any commercial or internal laboratory if you use. This system can handle data from any kind of a laboratory. After that, you run the quality assurance and quality control procedure and data analysis. And then you finally proceed to decision making and reporting and closing the project. And this system is not going to make the decisions for you. It can help the consultant to write the report, make the figures for the report, but the final decision making, where to drill, how to drill, when to drill, of course it stays with the customer, so the exploration company. So we have just provided some technical tools for you to run this process. So to go in more depth, basically this tool has two components. It's the data collection tool on the left-hand side in the middle, and the data analysis tool on the right-hand side in the middle. All this data is kept in the database, and that's the heart of the whole system. So in the beginning, the sampling planning is done externally from this software. It is a little bit too much to, because we didn't want to make this as another GIS program, and GIS is really needed to make a sampling planning, so that therefore the plan itself is made as a vector file and turned into a CSV point text file in order to import the coordinates into the database. After that, the next time you need to access need to come out of the system is when you are starting to collect the data. The data collection can be done with any kind of a digital data collection device. The output from the data collection tool is again a CSV file in very simple text format, and any kind of a data collection device can be used for these purposes. If you are using Windows-based, Android-based, even if you want to print it on a paper, you can still do it. But in the end, you're going to have a standard spreadsheet format, which is a CSV file. Again, you have to enter your data in. You can export it in this external data collection device into this format, and then you import it back into the data collection tool into the database. Then you work with the samples in the laboratory or in your internal laboratory, separating the twigs and the needles. You might want to add some standard reference materials. And after that, you can create an electronic lab sample list from the system. And this is a really cool part of it. You can add electronically the SRMs into the analysis sequence. The samples, the routine samples, are in a random format by themselves. It is automatically, the system is creating them in the random order. This lab list with the rest of the documents is being then sent to the external laboratory. And when you finally come with the result file from the lab, it can be imported into the data collection tool very easily and in the database. The cool thing is that when you do this sample planning, you give each point a unique sample ID. It is randomly generated by the system. And when you bring your external electronic lab list and send it to the lab uses the same codes, the same sample unique sample IDs, and these two will join up in the database automatically together. So this will ease up your further processing in the system a lot. You will avoid these mismatches of the samples from the lab and the field not matching each other. And then finally, you can run the QA/QC and the data analysis as Peter was showing before. And you can also export your data. In the current version, the data analysis is not complete at all. So maybe you have some preferred data analysis techniques you want to use with your own data. So you can export the data basically at any point of this system and take it into external software. This is what it looks like in practice. On the top, this is sort of like hierarchical. So on the top row, you can create the members. You can put any kind of a file in the material part. So this is sort of like a storage for photos, background material, contracts, whatever. You can create your sites, and then the data analysis is run here on the top row and on the right-hand side behind the analysis button. But the data collection tool It runs on the second row. You can see the blue row there. You make your plans, your observation points, plant samples, log sheet, field samples, photos, reference samples, and so on. So you proceed one sheet to another. This is like a logical steps you take from left to the right to proceed in the software in the process. Like I said, field data collection, it can be done digitally or manually. So the key is that the Gem web tool has a CSV file format that we called so-called standard log sheet. And you can export this standard log sheet from the system, store it in any format and manipulate it with any kind of a software you want to use. But then you also have to export it back into the system in the same Gem standard log sheet format. And after the field work, yeah, you upload it back into the Gem web tool. QA/QC, after the data collection is done, everything is finished, you go into the QA/QC part. Peter already earlier explained that it basically provides the means for selecting elements that are relevant for statistical data analysis. And the more advanced data analysis you have, for example, the multivariate quota analysis, the more careful you have to be what kinds of data, what elements you put into your final data analysis. So we have created this 6-step system. In the QA/QC 0, we look at the data overview. Number 1, process quality. Number 2, lab accuracy and precision with the standard reference materials. In step number 3, we look at laboratory contamination. And step number 4, lab precision. Step number 5, field precision. And after this, you are basically ending up with 2 different files. It is, or before you start interpreting this, you end up with 2 different files. The other one is a figure file. It's a PDF file, and the other one is a CSV file that you can open in your spreadsheet program. When you have these 2 in front of you, it basically takes you only about an hour to interpret that once you know what you're doing. But creating these 2 different files, it is very fast. It's about half a minute process once you have your data in the database. So this is why this tool is so powerful. You can do this step very, very efficiently and quickly. And then you can report back to your laboratory if you need to. This is what the QA/QC part looks. Here is as an example, QA/QC 1 on the top left shows you that there's some blockiness in your data. We already know what is causing this. We did not randomize the samples before we put them there into the analysis sequence. So there's different plant species that causes this blockiness. So therefore, randomization of the samples before you send them to the lab to see any kinds of trends in the laboratory analysis is crucial. In QA/QC 2, we use 3 different kinds of SRMs, and the lines in the middle show the pre-analyzed mean values for these elements, and the dots show the concentration of those homogenized SRM samples when they've been analyzed with my routine samples. And on the bottom row, QA/QC 3 is the laboratory contamination. Just very simply looked at with the box plots. The left-hand box plot shows the blank samples that laboratory has included in the analysis sequence, and the right-hand side your own samples. So you can estimate how big of a problem the possible laboratory contamination has on your analysis. And then eventually you come to the data interpretation part. And the purpose of this step is to find the spatial patterns and association of elements that will vector you towards the possible underlying mineralization. The ultimate goal is to recognize only the significant anomalies and separate them from the false and the non-significant anomalies. So you want to avoid the false positive targets, which are non-significant mineralizations. And you also want to avoid the false negative targets. So you want to avoid missing a significant mineralization. This is not an easy task. It requires expertise from the person who is interpreting it. And the system and the technical solutions will not do this for you. This is basically expertise that is built over time of the people who are dealing with this data regularly. Then we go to the another view from the analysis part of the software. We rely on the exploratory data analysis EDA, and one of the things you want to always first look at is the distribution of the data with many different ways. So on the left-hand side, you see the absolute concentrations in a normal scale, and on the right-hand side, you see it on a log scale. We're missing some of the features, like outliers, for example, would show in the Tukey box plots on the second row as cross plus signs. It would be really nice if we could select them from these plots and it would activate on a map. But this map feature we're still missing from the software, and it's going to be a future development. You can create very simple descriptive statistics tables with robust measures and regular measures. Oops, sorry. And you can do the correlation heat map, like Peter was showing before. Is it from the ILR transformed data, and look at the association of the elements in your data set. And you can draw line plots. So if you did your sampling in a transect, this system calculates geometrically the distance between the sampling points on the sampling line once you give it the starting point. So for example, here it would be number 357 on the left-hand side, the starting point, and then it automatically calculates the distance between the samples, even though they were not in a straight line. This example is from 2018 articles from the Juomasuo case, which is located in close to Kuusamo in northern Finland. It's a gold cobalt mineralization, and interestingly, neodymium is very high in this type of mineralization, and it shows really nicely as an anomaly in the crowberry twigs, especially in when the mineralization is subcropping, as a red line here, or the mineralization is at the depth of 40 to 60 meters. Another type of a visualization on the map you can do for your grid sampling. The scale on these maps, you can change it. You can do absolute concentrations with the percentile stretching for the colors. You can do a log of the absolute concentrations. You can do a CLR transformation, which is the only CODA technique we have on these maps. You can do a response ratio or log of the response ratios. And this example is from the Tiira gold prospect from Kittilä, and the data is from common junipers taken in 2015, and it's an arsenic concentration. So this software was done as a group work in the UpDeep project. The specifications were done as a group work by Scandinavian Geopool, GTK, Vienna Technical University, and VTT. The coding and the data collection part is done basically from scratch by VTT. And I believe this is the major advance in the geochemical data collection. This part of the software, it's really unique, and I haven't seen it in any other place. And let me know if you have seen something similar. I would be really interested. The data analysis part is sitting on top of this open source software called OpenVA by VTT. And the R codes that I showed you some examples as images before, they were done by Vienna University of Technology and GTK. And it's definitely not a complete software yet. And in the future, we'd like to expand it. We'd like to put some more sampling material there, depending on the projects and interest there is. So let us know if you think some certain type of a idea comes up to your mind, and we could do this as a cooperation. We want to bring in some more advanced multivariate compositional data analysis techniques in the future. And we would definitely have to add the interactivity between the maps and the diagrams. So bring in some very basic GIS capabilities, but still not make it into another GIS program. So thank you very much.
Thank you very much, Marit, on this great presentation on GEM web tool. We don't seem to have any questions there chat, but I could say that this is definitely one of the main outcomes of the project. I could ask something. Olli is typing. While he's typing there his question, I could ask one. In user point of view, how do you consider, how difficult is it to learn to press the right buttons? I mean, is there any training required? Is this a difficult software to learn?
Yeah, it is. We try to make it as self-exploratory as possible, but this is the first version of it. So there is a lot of improvement from the user point of view. We have a manual. We have written it during this project, and it's about 100 and some pages. It is very, very detailed. So it is basically the way to learn, just to start using it and take the manual open and going with it step by step. It explains the theory behind and also like what buttons to push. So I think the manual is the way to start. And we also yesterday we recorded a video to how to use it. So that was basically be the future of it. Watch some videos on your own time and read the manual. And also if you require to, and once the software is commercial, I'm sure training will be provided as well.
Okay, so now we have a couple of questions here. Olli Salmi is asking, who will use the software?
Well, it is it's a software tool that all the parties of the project would use. So first level would be the system manager, who would be in the company that hosts a server. So the system manager would basically manage who will be able to use it and make any kind of a database modifications. Then you can have a project manager that has a lot of privileges. He can see or she can see everything, all the data and all the steps required. Then the customers, which would be anybody from the exploration company that was given a password and a username, could use it and follow the process of the data collection and data analysis. And basically, the exploration geologist or geochemist can also do the data analysis in the software themselves. They don't have to only rely on the consultant to do it for them and follow the process that way. So, and thirdly, of course, the consultant geochemist. He or she would be the first person to use it actively and follow the process. And the field crew. So if you have a trained field crew, you send out to the field for excuse me, collect the samples. They would only have an access to input new field data into the system, but they wouldn't have an access to view much of the other stuff that is included into the project.
Okay, yeah, thank you. So plenty of potential users. Mattia is asking about the link to the software, if available.
Well, right now it doesn't exist. We're just correcting the last bugs, but if Martia would be willing to test it, and once the software is installed on a GTK server, we could give you some access to it. So potential testers, we can create you an access to go and see how it works.
Okay, thank you very much, Marit. I think we need to move on. The next presenter is Nick Cook from Mawson Resources, and the title of his talk is Surface Geochemistry in Exploration. Nick, please, do we have your presentation loaded?
Nick painoi vahingossa stop sharing, niin se meni alkuun. Kelatkaa sinne, missä olitte menossa.
Okay, let's wait a while until we will find the right presentation. So it's the next one. Okay, here. So Nick, now floor is yours.
Nick, remember to click the microphone button from the up panel. So.
Hey, yeah.
Yes, we can hear you now.
Okay, great. Thank you. And can I use the pointer? Yes. Okay. Good evening, everybody. It's 5 to 11 p.m. here in Australia. So it's a pity we all can't be together, but there's a great turnout. So what I thought I would do is try and give sort of a practical background to what we have done in our project with reference back to this project and where I suppose we see it going. So, I'm happy to answer any questions as we go. But so first up, let's just, we actually need to think about what's going on here in these systems. I mean, unfortunately, this is not the case in Europe, and most things are not sticking out of the ground, especially in Finland. So we're facing up with essentially the reality for us in exploration and in Finland and lots of Europe, where it's either covered with agricultural material or till. So we have this in winter, quite a strong contrast to here in Australia, and the summer view looking something like this. And there's a number of things I suppose I want to make a point about in this talk, and it actually partly relates to the composition of the till, and it relates to the composition of the basement. And not only that, I'm not sure that we actually understand the true interaction between our signals that we see at the surface and what is actually going on in the basement rocks. So I'd like to think a little bit about that as we go through this talk. And unfortunately, the animations are taken out of it, so you'll have to pretend you don't see the bullet points until I actually get to them. So what were the goals of this project? Well, create a geochemical exploration consulting service. We really wanted to basically have a low impact surface geochemical method that uses the selective and weak leaches of soil horizons and plants to come up with anomalies, geochemical anomalies, I think you could say that we understand, and to allow us to find ore deposits. And I suppose in our world, it's drill lower risk targets with minimal impact, because it's very easy to create anomalies in geochemical data, and you want to be fairly sure that you're going to drill something that is has a moderate chance. Now, we're never going to be 100%. It's a bit like geophysics. People out here in exploration know all about drilling conductors, and a large number of them seem to be graphite or carbonaceous matter, and occasionally they're sulfidic. And I think we have the same problem in geochemistry, and we shouldn't ever believe that we're going to come up with a complete method that will not produce false negatives. But there are ways to minimize some of those false anomalies. So let's just think for a start about what we're dealing with in Finland.
One, glaciation. So essentially physical dispersion for a start of materials. And nice photo of Greenland on the right-hand side there, on the way to PDAC a couple of years ago. But then on the left-hand side, we really should be thinking about what are the processes in the basement to release the elements that we're actually looking for. What is going on to produce the sorts of diagrams that we see on this next slide. It's not uncommon to see these, but in many cases, I'm not sure we actually understand how those elements get there, how they produce an anomaly. And we've had lots of attempts, and we understand some things about it, but I'm not convinced ever that we know completely how these elements get shifted around. But we are moving in that direction, and projects like this in particular help us get there. So let's start with our project here about 40 kilometres west of Rovaniemi. And we started in the project in the western side there in that area called Rompus. And I've put on some boulder sampling that was done. Now those boulders were found actually with a scintillometer because there's uranium associated with gold. And a lot of the boulders are either very anomalous or slightly anomalous in uranium. There are also many of them exceedingly anomalous in gold. And when I say exceedingly anomalous, up to 4% gold. So that's an extraordinary background, I suppose, in material to start the exploration process. And the glaciation, Pericles had a look at these rocks, and the till largely comes from the west to the northwest, the glacial direction here. So we have an idea that these boulders have moved in a particular direction. One thing about boulders is that in order to remain a boulder, if they've moved any distance at all, of course they're hard. The soft ones break up very, very quickly. And what you will discover out of this map is that something like 95% of the boulders are not associated with the resources that we have published to date. In fact, there's only a couple of boulders in the east at Polocus. I think I can use this. I'll do that. Boulders over here at Polocus, and just a couple in the surface at Raya. There's a big boulder field here, and perhaps that's related to another system that is maybe more continuous. But the question is, what's the signal from the bedrock versus the transported boulders in the till? So when all of these boulders end up sitting in the till, do they actually provide a response that is masking any of the signature that the basement might be making to stick through this? So that's one thing that we ponder as we look here. But boulders, classic way to work in this part of the world, but we're trying to go past that in this project. And so if I look at our data set across that same area, we have made lots of AH sampling, so essentially weak water, almost you would call it, to look for anomalism in the the material immediately below the leaf litter. We have tried hand till sampling. We've tried lots of base of till sampling. We've taken lots of rock chips. We have panned, and we have actually looked also for microbiological gold. So the base of till rig, the photo in the top there, has sampled lots and lots and lots of material within, and so that dense area there has all been sampled with base of till. Now, what do we see in that? Well, I wouldn't say it's easy to interpret, in that you tend to, and this is reality rather than ideal based till, you tend to get a mix of basement signal and a complex signal that's associated with clays and perhaps some metal ions that are absorbed into the base of till material. But of course we have the situation that we have both the physical transport, in this case gold and scheelite commonly, gets mixed up in the chemical transport of elements from the basement. So we'll come back to this in a little while, but it is not easy to interpret all of that data. Now the colours here we'll come back to. This is regional till data, and there's a whopping great anomaly from some other till data right in the middle here of gold and antimony from the original GTK till data set. Here's Rumpus, this striking ridge up to the north here with lots of anomalism at the northern end here, with gold in outcrop as well as in the till. So have we got enough data? Have we done the right things? Or is there another way to go about this problem, to go about the sampling? And that's the game, obviously, here in this UpDeep project, to see if we can reduce the expenditure, which you can see here has been moderate, on this project, to find essentially resources now at Polocus, South Polocus and Raya here, which are gold and cobalt. So let's go to the basement and think about what might be released from one of these mineral deposits. So I suppose I think about some of these systems slightly differently to most, and that here we have a mineral map with by QuemScan from Alan Butcher and his team of the mineralization at the Raya prospect. And you can see the list of minerals down the right-hand side. And then if we looked at, in a different format, we looked at 3 different samples and looked at the mineral relationships in those rocks. How are we going to use that data to understand a weak geochemical response? Well, I am not convinced yet that we actually understand the contributions, for example, of 2 or 3 different cobalt minerals and how they actually provide a response in the overlying till. And second to that, does it actually matter if we understand it, if we get an anomaly in cobalt, for example? And perhaps the argument at the end of it would be that if above these mineralization, if we see anomalies that actually mean something and have some sort of interpretation, that might be as far as we can go. It might be as far as we can go. But statistically, it would need to be a good anomaly. Let's take a slight diversion to the world of plants. It always intrigues me in these places that we have 5 to 6 meters of till, and even above that till, it appears to the plant populations appear to be controlled by the basement. These are in the Finnish system called UHEX listed plants, in this case orchids, and unfortunately this long ridge at Rumpus here contains lots and lots and lots of orchids that preferentially like growing on alkaline conditions. Now those alkaline conditions are controlled by dolomite veins, and the dolomite veins are what controls the uranium and the gold, which is somewhat of an unfortunate biogeochemical anomaly. Over to the east here, I grab this arrow over to the east, over this side, in the Raya Palot region, you will see we lack these orchids. There are a few here and a couple of other locations down here. So our current project is over in this part of the world. Well, what does that actually mean? So we know something about biogeochemistry. We go out and we sample twigs and we find certain elements. In this case, we're actually using these data for other purposes. So you need to match. One thing here about these sort of data is you need to go back and match the geology. And the comments made by a number of people saying you cannot just get a consultant to come in and look at the raw data and not know something, not have an interaction with the geologists and the people who know something about the mineral deposit. It is key. You could, for example, plot in the AH data, and this is what we did, we plotted the magnesium-calcium ratio, essentially to look at alkalinity, and it does, in general, match. So the peaks match places that we see orchids, and over here in the east side over here, there is lower alkalinity. And that does match the lack of carbonate in the host rocks to the mineralization. Well, we all know about bugs or microbiology and metals in their activity, and we can use it at a very large scale. And we know it goes on in our rocks. However, the actual control on what the microbiological community is doing to our sampling and our destruction of the rocks and the introduction of the metals into the overlying soil profile, I would argue, is not particularly clear. We did have, the name escapes me now, Frank Reef, came from and worked with GTK, and we did some microbial sampling for gold, and lo and behold, we found some. But the problem was here is we already knew it was there, and so these methods need to be operable at a scale that allows you to do exploration rather than proving it was there after we actually found it. And notice here that I have gridded the AH sampling for gold in the background here, and there is actually no peak at Palocus related to the AH sampling that we did. However, the microbes appear to have taken up the gold in some way. So there was a comment about positive and false negatives, false positives, and the data again. These are the cobalt base of till data here. And I've drawn 3 circles on here with cobalt data, and you will see the red anomalism up here, red anomalism here, red anomalism down here in this part of the world. So why would we not go up here to the north? It looks like the best anomaly. And in fact, when you look at the geochemical data here, it matches some of the characteristics of our mineralization. However, it is black shales are responsible for that, essentially though, that element anomalism inside that circle. And so once again, we need to use our local geological information to essentially normalize the results or work out what other elements might lead you to understand it. And one of the things I would always say about these sorts of projects, and you know, when I saw in one where it said, we wrap up the project, we write the report, one of the best things you can then do is go back to the data a month or 2 later with the consultant. So if you have a consultant who comes out to look at these data, get them to work with your geologists, because otherwise you will end up with a circle on the map, such as this saying, drill here. It's the most consistent anomaly. Well, it is, but unfortunately it is a signal that is caused by something else. So we could go to the next level. There's a fascinating paper on soil microbes and the like, and you could go right down to the nanometer scale in the soils and work out what's going on. And do we actually have to go to that level or not? Well, perhaps, and it might be worth considering it. But it might be worth just taking some weathered rocks from immediately underneath the basement surface and looking at the bulk rock geochemical changes in those as to what is actually going on in the weak weathering that goes on underneath these systems. So we are moving in the next project, EU-funded project, further down the track into characterising more of the materials around these anomalies. So we may get some of the way down the track. But if anybody's interested and hasn't seen this paper where this diagram comes from, I'll post it to Marit and she can distribute it if people want it. So where are we going? What are we doing? Right, sorry, this has just changed around slightly since I wrote it. Okay, so then what are the next key aspects? Well, one of the keys, I think, for everybody is to continue to somehow increase the signal-to-noise ratio. And there, with these low levels, we talked about precision and accuracy, there are some processing issues that everybody needs to come to realise, including almost getting down to the stage of levelling your data sets at low levels, because anomalism is not particularly easy. And it was great to see some attempts to produce some multi-element anomalism or multi-element data to try and sort of see through some of the issues with signal-to-noise ratio. I suppose I'd like to see some more detailed use of rock weathering studies to determine and calibrate the release of metals into the water column. But I think that's largely controlled by localised geochemical microbial controls in the soil. So it may be that we just choose one set of trees, and because their roots pass through and are averaged out, because they're in similar compositions, we may just see the anomalism. It is actually, it means that some of these localised effects become, I suppose, less important. So we need to think about what are efficient methods to normalise the anomalies on the basis of the plant species. As Marit has discussed, we're taking measurements of local pH. We need to always, and this is easy to say as a geologist, get back the bedrock control and think about the other things that are that may actually control some of the short-term variations in the false anomalism here. So how are we going, and are we getting there? I think so. So I'd like to say thank you very much, and keep up the data collection, and we'll keep that signal-to-noise ratio going, and hopefully we will be able to spend some money drilling some of these targets that are created through this project. Thank you.
Thank you very much, Nick. Do we have any questions on chat? Not yet. No, I can say that this Rajaplot rhombus is really a fantastic target, not only for mineral exploration, but also for research and innovation and development of exploration methods. Definitely.
We're lucky that there's no disturbance there.
Yeah. Well, can you pick one geochemical exploration method that works kind of best in your complex target area, or is it more like using all different methods and data integration is the answer?
Well, think it has to be more integrated. So I don't think there's a single geochemical method, although some of the latest next projects on the cobalt values look like this, the cobalt anomalism is reflecting the basement. I haven't seen any of the tree data yet, but I would be surprised if the tree data doesn't produce some useful signals as well. The base of till data was a good basement mapping exercise, but and there's some anomalous zones, but I would say it has not for us been the best area. And it may be the nature of the till itself that's not as good as the till, say, to the north, where there's a bit less transport. So there's a little bit of that.
Okay, thank you. Well, I cannot see any more questions, so I think we should move on. Or, well, Olli is typing something.
Okay.
Okay, no, it was just about his presentation. So thank you very much, Nick. So the next presenter is Olli Salmi from EIT Raw Materials, and title of Olli's talk is UpDeep Project from the Perspective of EIT Raw Materials. And Olli.
Hello, can you hear me?
Yes.
Good.
Loud and clear.
All right, good afternoon, everybody, and I'm very honored to be the last presenter before Vesa's wrap up here today. And well, wait to see my presentation coming on the screen. There it is. So let me just start by congratulating the UpDeep consortium for a job well done. And the presentations today, of course, are very convincing that this topic and field is important. And as Vesa pointed out in the introduction, and later also Nick, that even though Australia and Canada are leading in this field in Europe, in this field of exploration in Europe, we have the know-how, we have the right geological settings, if you will, or whether that's a blessing or a curse, I don't know, but to employ these type of technologies in the field of exploration, especially with deep cover or remote locations. What a funding support organization like EIT Raw Materials thinks in these kinds of when a project has come to an end, of course, is, well, first, has the project met the objectives? In the case of EIT Raw Materials, typically have we brought an innovation to the market or towards the market for those who are operating in the market for their use? And the second one, of course, is how does this fit into our overall portfolio? What is the bigger picture that we can make out of the activities that we have been funding? And of course, UpDeep does complement our portfolio. I'll come to that in a minute, because we do not really have such projects that would allow these kind of subtle geochemical and geophysical signatures to be identified from large distances from this primary mineralization. So in that sense, it is a fairly unique project that we've had, and of course would like to see what the future brings into this project as the next steps. Of course, as Nick also was pointing out, this is not a silver bullet, so you will probably need other methods to be integrated into this one. However, I do think that there is a benefit that is beyond what we've heard today in this approach, and that's the lower environmental footprint. So we can establish less invasive exploration in the mining sector, which, especially in Europe, for places that struggle with the social license to operate, hopefully help in gaining better conditions for geologists, for prospectors and developers to do their work and advance towards new mining and, of course, new investments in Europe. And I'm going to probably wrap up with roughly the same remarks, but let me now take a look at the
the portfolio that we have in EIT raw materials in terms of exploration. So taking a few step backs, I know that we have still quite a few people in the audience, and not everybody maybe is so familiar with what EIT raw materials does and how we work. So we do have specific key focus areas that we support with funding. These are what we call lighthouse programs, and there are 3 of them. And of course, exploration projects like UpDeep belong to the one on sustainable discovery and supply. But as the EIT raw materials covers the whole value chain, so we also look at sustainable materials for mobility, and then circular economy and raw materials use in society. But if we look at the sustainable discovery and supply area of EIT raw materials work, then of course what we want to achieve is that we have a better understanding of how Europe can supply itself with the critical raw materials, metals and other minerals for European industry. And this means that we start all the way from exploration prospecting all the way to mining and processing, to make sure that we in the future are in some cases less dependent for non-European production, but also for sure that we get a stronghold in strategically important value chains for European industry. For instance, the battery value chain that was somehow indirectly also touched upon by Nick in his previous presentations on cobalt and the BATCycle project. So to secure the supply of raw materials in Europe is the key cornerstone in this lighthouse, but also while doing so, to do it in a sustainable way that we can actually improve the whole sector from the start in terms of environmental and social sustainability. This might be, I'm not sure if this is a very readable slide, but it's a bottom-up representation of our portfolio, especially in this lighthouse sustainable supply for the portfolio that we have. So we have 3 main areas there: resource efficiency, digitalizations, and then machinery and tools. And now if we populate that view with the entire portfolio of exploration, mining projects, we have a fairly good balance on activities. What we don't really have, I mean, there's one blind spot there on artificial intelligence. We don't really have in AI projects in our portfolio for digitalization, but otherwise we have fairly well represented in this respect. UpDeep, of course, comes up there in several different places. So we have 3 different kind of slots there in characterizations. One, of course, in machines and tools, also for remote. We feel that there is a benefit also for these remote locations. And of course, data inventory development, which was so nicely presented by the previous presenters on the database, and also the digital tool that you guys are developing out of the UpDeep. If we look a little bit further on what is still missing from our portfolio, what would be the next UpDeep, if you will. So we did several of road mapping exercises on what kind of activities do our stakeholders, our partners and other stakeholders feel that are important in the sustainable discovery and supply thematics. So from geology to technology, ELS, environmental legislation, society, economy, and all the way to education. So not going to the details here, but from geology, resource assessment, on technology, a number of different mining equipment, remote sensing, drone, drilling, core logging activities have been perceived as important. For environmental legislation, society, of course, health and safety, water is a big thing, tailings come up there. For economy, not very many clear targets have been identified so far. Of course, we also do not have very many projects on those fields. And finally, education. which has a fairly broad. You don't go into, well, we should have geochemical education, but it's more on generic skills or skill sets that students are expected to acquire while taking EIT raw materials funded courses. So if we take now a look at on what kind of activities we have here, we have the education project acronyms here in red, and upscaling is with the black. UpDeep we have up there with the geology field. So we have a fairly good coverage of a number of projects in these fields also here. In technology wise, or maybe that's a more of a value chain perspective, but we do not really have a project here that would cover the entire supply chain and logistics. And of course, this is an area that, especially now in these times of coronavirus, it is quite clear that we would need more innovation, more knowledge on how to protect the long and vulnerable supply chains and logistics into extreme cases like we are experiencing right now. So this is for sure something that we will look into in the future and see what we can have our bit to do there as well. For one more lift there for the education part, and this is quite interesting that we do have several education projects also that EIT raw material supports on exploration and mining, but a lot would still need to be happened there. So on regulation or innovation skill, understanding the production processes, understanding the business from the very upstream perspective is something that we feel that is still missing from our portfolio in terms of education. But we can already say now that with the great number of projects that we have so far funded, we seem to have achieved a very nice portfolio that will respond to the challenge that we set upon ourselves in the European field in supply security and new discoveries. Probably skip over that one, but this is the final slide that I have here on how should I say who is doing what, the top 10 partners in exploration projects in Europe right now with the EIT raw materials. So we have there on the right hand side the number of activities that different of our partners are involved in. For instance, for GDK, 10 different exploration projects that you guys are involved in. We have BRGM involved here also in this project. So it's I think it's a very good group that we have. It's a very good community that we have with different universities, research organizations, especially the geological surveys, of course, that are running these projects. And we would like to see, of course, in the future that the steam goes on and we get equally good projects up and running, especially towards market introduction and market uptake of the results that you guys are getting from these projects. So wrapping up here, I think that where I started that in addition to the UpDeep methodology surely being an important addition to the toolbox of an exploration geologist, we do see a more or a broader impact possibility here towards the social license to operate. And I would encourage you and recommend you strongly to also see this as a promotion and a marketing point of view. So I'm not a geologist, I'm a chemical engineer from background, so I probably know something about chemistry, but not about exploration that much. But even so, I do understand that justifying collecting twigs and sticks and plants is a lot better. It's a lot easier for many people to accept than going drilling holes and start breaking rocks. So I think that this kind of framing of this approach as a how would I say, sustainable and a soft way to start looking at where we have these important minerals for the European economy will be a definite asset for this kind of approach, and in my mind should be used in the further business development on the area. So again, congratulations for the projects well done, Vesa and the team, and be happy to have any questions if you have for me. Thanks.
Thank you very much, Olli. It was very nice to see and hear how nicely UpDeep really fits into the EIT materials portfolio. Okay, do we have any questions to Olli on chat? Not right now. Yeah, you mentioned about this sustainable exploration technologies and social license issues, and we actually do have a Horizon 2020 project going on where we are developing new exploration technologies, and this project was really justified based on these sustainable new technologies, and these geochemical exploration techniques were one of those that are developed in this project. So you are right. In this case, we didn't include this this part into the project, but yeah.
No, but I think that we can cooperate there in the future, and we can be in contact with some of the project partners, see if we can together make a bit of an effort on creating awareness of these types of methods and this type of new industrial approach, if you will, to exploration. So.
Well, if there's no specific questions to Olli, now there is also possibility and time to make questions to any of the other presenters today. So feel free to type questions on the chat, and we can pick those questions. So first one is coming. And any of our experts can be ready to answer the questions. Do we have any? Or can be also comment if you don't have any specific questions. Well, it seems that there's no questions or comments coming from the audience, so I think it's time to wrap up the meeting. So it's been a long afternoon. Really sorry about the technical difficulties we had at the start, but it seems that everything is working nicely now and most of the time. So now it's time to close this meeting, and very soon time to close the project as well. First of all, I want to thank all the speakers of this seminar. Thank you very much for your contribution. I want to thank the project team for its great effort during these 3 years, or actually it's 4 years, because we started our journey together 4 years ago, approximately these days, with planning the project. We used only 1 month for our successful project planning. In fact, that's all what is needed when you do it right and do not spend your time wrong. And I want to remind you, I don't know if you guys remember, but we did it all online at that time too. We did not have any physical meetings when we did our project planning. My special thanks go to my deputy project leader, Marit Middleton, who has been doing so much work keeping things going on and on track, even today, as you saw. So that without her, we would have been lost long time ago. Also, I want to thank our bookkeeper, financial counselor Tuija Villikka, and legal counselor Nina Isokorpi. Their contribution has been valuable for the project. It's been great pleasure to work with our partners, Geological Survey of Denmark and Greenland, Geus, the French Geological Survey, BRGM, Vienna University of Technology, Scandinavian Geopool, VTT, Spinverse, and LTU Business. This project received funding from the European Institute of Innovation and Technology, EIT. Surface geochemistry has played a key role in several discoveries globally, and I could give a couple of examples, just recent papers. For example, the Northern Miner recently reported a gold discovery by Marmota Limited in southwestern Australia. Another example comes from Canada. A treetop sampling program in British Columbia led to the discovery of a massive sulfide zinc prospect reported by Dunn et al. This was in Journal of Geochemistry a few years ago. The results of UpDeep project indicate that there is no reason why surface geochemistry would not also be successful in Europe. Although many explorers are already utilizing it, exploration industry will benefit from the advantages only if majority of explorers get familiar with these techniques and adopt these in their palette of exploration techniques. The cost of running surface geochemical survey is a fraction of that of traditional exploration techniques because mobilization of drilling rigs is not required. As with any other exploration method, surface geochemical techniques are not bulletproof. The risks, however, can be minimized by intensive communication between exploration geologists and expert surface geochemical consultants. If explorers are willing to accept dealing with the risks and integrating surface geochemistry into their company's exploration strategy, they should also be prepared for the consequences of hitting deep-lying jackpot. The UpDeep project outcomes will help make this an interesting journey. Well, some of us have already continued the same field of research in another European funded project called NEXT, New Exploration Technologies. And I've been referring to this already before. And this is also coordinated by GTK. Furthermore, just recently we have applied funding from the EIT Raw Materials Lighthouse program for a new project dealing with the surface geochemistry and data integration method using machine learning and artificial intelligence. And some of the team of UpDeep is involved in this project as well. So, although we are going to shut down our microphones now, we are not going to disappear from the scene. We'll be back. Thank you for joining us with this journey today. Stay healthy and stay safe. Thank you very much. And the meeting is closed.